Okay, well, good afternoon, barely. My name is Dele Ogunsheto, and I'm delighted to welcome you to this year's program in public health. We've been conducting the seminar series for almost 5 years now, and we bring people from all over the country, all over the world, to visit with us in public health at UC Irvine. But we also do open it up to the entire community. And the reason we do so is because in many cases we value the interaction with our colleagues across campus, but also outside practicing public health in the agencies. I have to tell you, in the 5 years that I've been hosting this seminar series, I have never actually given one, so this is a first for me. We also are very thankful for the Office of Extension for helping us record the seminar series through the OpenCourseware program. The videotapes are available at on YouTube, but also on their website, and we link also from the UC Irvine Public Health website. By doing so, we've been able to reach thousands of people worldwide who visit the website to listen to the experts who have come here to share their knowledge with us. These experts are selected based on the network of our faculty and students. So any one of us can nominate speakers. We typically fill up the roster about a year in advance. But at any time, if you think of a topic of interest or somebody that we should get to know better, this is a good opportunity to invite them to our campus. In addition to giving us their knowledge, we also invite them to stay for lunch after the seminar. So you're all welcome to join us for lunch at the ground floor of the Anteater Instruction and Research Building. I just said that hoping that not all of you will actually show up because we don't have enough food for everyone in this room. But you know, sometimes a topic is fascinating enough for you that you want to get to know the speaker better. Sometimes it's because you want to discuss a particular question that we didn't get a chance to cover. But please rest assured, if you do show up, we will make sure you don't go hungry. So please take that offer seriously. I know not everybody can stay after. I also want to make sure that as we go through this series for the year, that some of the students are enrolled in a course that gives credit for attendance. We don't typically take attendance here. I expect that you submit a summary of your assessment of the speaker's presentation and your independent knowledge of the literature in the week after. So that's how we grade your participation in the course. But also feel free to ask questions during the presentation if the speaker allows it. For me, it's okay. Other speakers are less agreeable to that and would rather wait till the end of the seminar. Again, thank you for showing up today. I'm going to talk to you about the work that I've been doing mostly the past 15 years. Most of it is collaboration with colleagues across our campus, across the state, and sometimes internationally. I'm not sure which one is better. Okay. But it will be a major review of the efforts that my colleagues and I, our students, those who are more advanced than I am, and those who are just beginning. So this is going to be kind of a marathon. I have a lot of slides, but I don't want that to be the reason we don't discuss anything in detail. If you have questions, as I mentioned, as we proceed, please feel free to raise your hand, and I'll keep my eye open for those hands. The outline, I hope we are able to cover all of the this numbering is off. This is what happens when you transfer from Mac to IBM. Anyway, there are 7 topics that I hope we cover. And we've done work on almost all of them. I will occasionally refer to the work done by my colleagues as well. So let's begin with the global view of urban solid waste. This is a map of the population growth globally. The red dots are cities already more than 10 million people. The yellow dots are people with orange dots, 5 to 10 million people, and the small yellow dots are 1 to 5 million people. The projection of the United Nations Population Department is that by 2050, urban dwellers will probably account for 86% of the population in developed countries and 64% in developing countries. The trend has been upward for at least the last 100 years. And what this means is that the infrastructure that supports urban environments and urban populations have also evolved and changed rather rapidly. The technological innovations that have given us products for transportation, for energy consumption and storage, for healthcare have also been concentrated, but so are the wastes that are generated from this infrastructure. And that's also been a major concern of the World Bank. In 2010, for example, the municipal solid waste generation was about 1.3 billion tons per year, projected to go up to 2.2 billion by 2025. And each one of us, the per capita waste generation rates, from 1.2 kilograms per day to 1.42 kilograms per day. These are World Bank categories. These are regions of the World Bank. Obviously, African region is still very low in terms of per capita generation, but that's projected to also increase by 2025. The largest category, of course, is the Organization for Economic Cooperation and Development countries, typically not included as a World Bank region. But for comparison, the United States falls into this category, 2.2 kilograms per day, projected to decline a little bit because of some of the conservation efforts, but almost everywhere else, the number is supposed to go up. So this is a concern because, in fact, the management of waste is one of the largest budget categories in any city's expenditure. One of the biggest cities in the world, New York, published a book recently called Taxes In, Garbage Out. New York City spends $2 billion per year managing their solid waste. Part of the concern is also that they're running out of land to landfill many of these wastes, so they ship them out to other states at the expense of having greenhouse gas emissions, unnecessary transportation, but also in terms of the billions of dollars in costs that countries that cannot afford such expenses estimated to go even higher as a proportion of the current baseline cost than some of the established economies. And part of that is the technology that's also been developed to make sure that waste is recycled and compacted. But it is a major concern because this is money we could spend on other things that are priorities for human welfare and health. So the solutions have been source reduction and recycling, as I mentioned. And this is where the US stands with respect to mostly European countries. The greenish line is where things were in 2001, about 15 years ago, and the orange line is where things were in 2010. For the US, this is where we were in 2001 and where we were in 2012. So about 35% of our waste is recycled. There is a lot of progress. Austria takes the crown, but that's still a lot of materials being thrown out that we have to find space for, and also to prevent the impacts that I'm mostly going to spend the rest of this presentation talking about. If we look at the rates of recycling, now this is the United States. We're very proud of the rates of recycling of lead acid batteries. We're all responsible for, if you drive a car, you have a lead acid battery in your car, unless you drive one of those newer versions like the Prius with the lithium-ion batteries or the electric cars. But 99% of cars on the roads in the US use lead acid batteries. And we were extremely proud to have this level of recycling because the EPA promised to give us $10 each if you take your old batteries to Sears and get a new one. You get a $10 rebate. Now, what happens after you dump your old battery at Sears has become recently a cause for concern, which makes it very difficult for us to celebrate this high level of recycling. And that's what happened, and it's been happening for the last few years at Exide, right here in Los Angeles, Southern California region. So most of the batteries that we claim to recycle actually are shipped outside of the United States. And this factory in Los Angeles is one of less than 5 nationally that recycle lead acid batteries. And if you've been following the news recently, you would have noticed that the neighborhoods that are affected in the Vernon region of Los Angeles have been protesting almost every month. There is some event going on. The director of the California Department of Toxic Substances Control, Debbie Raphael, had to resign earlier this year, in part because of the turmoil associated with people really making claims about the complacency of the agency, but also the fact that they have not given Exide Corporation the kind of discipline that people expected. I hope this works, but I wanted to share with you a recent video to show some of the concerns that people have about the Exide facility.
Park in East Los Angeles today. A few yards away, the playground was also deserted. There were no children to be seen here because they're being sheltered in place, kept inside because the levels of lead outside were recently found to be, to quote a report, elevated. The finding was frustrating for women who come to the park for Zumba classes to improve their health.
That's really dangerous. Things need to be done here to improve the safety for the children. That should not be happening. We're in 2014. This should not be going on.
Mary Casas teaches the aerobic dance classes.
It concerns me because, I'm here helping people, trying to get healthy, trying to get fit. So it is a big concern. So I hope they do something about it. If it's a big thing,
It is, and Gloria Molina has. At today's meeting of the County Board of Supervisors, she proposed the formation of an interdepartmental task force to be called the Toxic Threat Strike Team.
In order to either get these toxic businesses to respect the surrounding community and put in place the safety measures that are necessary, or, if need be, to close them down.
Her motion passed unanimously. The lead found at Salazar Park allegedly came from Exide. It's the battery recycling plant in Vernon, less than 3 miles away. The company released a statement today after California's Department of Toxic Substances Control, the DTSC, asked for more comprehensive inspections. Exide, the statement says, will work cooperatively to conduct the requested additional sampling and the interim cleanup measures. But critics believe Governor Brown needs to get involved.
The governor needs to tell the DTSC to take action in the form of having that company actually put their money where their mouth is. They can afford it. You know, our public health should not be mutually exclusive with corporate profits. Health and wealth should not be mutually exclusive.
In Los Angeles, Tony Valdez, Fox 11 News.
LA Mayor Eric Garcetti says he
Okay.
has a mandate to...
Thank you. Health and wealth should not be mutually exclusive. And I usually query my students to tell me who they think said this. The history of child-led poisoning in the past century in this country is a good example of how powerful economic interests can prevent the implementation of a useful truth, which is the removal of lead from most of the products that we use. I'm not going to let you guess, but this was one of our founding fathers, Benjamin Franklin, almost 300 years ago. And so we are essentially in the same place we were when he made this claim that people believe that economic interests are still more important in the way we formulate environmental health policies as they were several centuries ago. And this is a problem that we can no longer ignore, particularly because if you look at the places all over the world, this is a map of the world according to the Green Cross and the Blacksmith Institute for the last 10 years or so. They go around the world investigating about 3,000 sites, and they come up with the top 10 worst, most polluted places in the world. Typically, on the top 10, at least the last, I think 2006 and 2010 assessments, most of the sites were lead mining or lead acid battery recycling facilities, just like we have in Vernon, Los Angeles. But for the first time in 2013, the top of the list was this place in Ghana, where I have visited, called, it's a electronic waste recycling mining site in Ghana. And the reason it came up on top this year is the sheer number of children who are potentially exposed. I think it's about 40,000 children who live nearby who are exposed to the direct toxic risks of the mining operation. Ghana imports about 150,000 tons of electronic used products or recyclable products, they call them, every year. But instead of having an organized way to refurbish or to take them apart, typically it's done through these artisanal operations where people burn the plastics off, hoping to collect back the semi-precious metals. And this has led to a lot of contamination and human health impacts. So I'm going to talk about why urban mining of electronic waste is risen so rapidly and why it's become a big problem for children's health, as recognized even recently by the World Health Organization. How many people here have their iPhone 6 already? Okay, about 7. How long did you use your iPhone 5? Terry, 2 years. Okay. You're part of the problem. I'm kidding. Hopefully the solution after this talk, yeah. So I think we all want the newest gadgets. We all want the best technology that's available, and it's a good thing. I'm extremely supportive of innovation and technology development. But in the last 20 years, as you can see from this graph, This is sales of electronic products beginning around 1990. We're in a logarithmic growth phase. The blue are mobile units, particularly mobile. So you can imagine what's going to enter the waste stream a few years from now. This ends in 2010, and you can see the mobile devices still at the tip of the iceberg. But that's the biggest growing category. And the reason these are particularly concerning is that they are so small that, and they don't last long. People use them for 2 years, and you're ready for the next one. And even if it's still working, and so they're contributing enormously to the solid waste stream. But they're not like plastics or cardboards, because these are potentially hazardous materials. And that's part of the concern we have. If you look at the recycling rate for electronic products, the green bars represent recycling rates, and the blue unrecycled products that are disposed of. Definitely less than the 34% average recycling rate for general urban waste in the country. But you can also see that the blue region is expanding, which means that more and more, even though we're increasing the recycling portion, very likely for mobile devices, the numbers that we are not recycling, that we're disposing of either into landfills or burning or shipping overseas, are going to continue to rise. The problem, if we just threw them away, is that they're actually depleting a lot of resources. So this is an estimate of the amount in tons of precious and semi-precious materials and rare earth materials present in electronic products. This is just the mobile component. So a lot of copper, aluminum, iron, and some gold that we throw away. By some estimate, 20 tons of gold, about $16 billion, used to manufacture electronics every year, and only 15% are recovered. That's a lot of money that we throw away. What this has done is to create a demand by those who want to recover that gold, and the shipment across countries of electronic products that are no longer being used in the United States now end up being shipped to Asia, primarily China, but also a big chunk of it goes to Western Africa, and from Australia to Asia, and from Europe, pretty much all over the place. South America also takes some of this, particularly Mexico and Brazil. A lot of the work that we've done are basically around the West African region and also in China, because that's one of the largest markets, to recover very small amounts of gold, platinum, copper from these wastes. In return for the amount of precious metals that these small-scale workers get, there is a tremendous amount of pollution of the environment, and also direct impact on the children who work in those cottage industries. So we began writing about this. This is a very popular piece that was invited in 2010. It's been translated into several languages. And it is essentially a gold rush. The piece was titled The Wild West of Electronic Waste, really pointing out to the volumes that are being transported across the oceans to these countries, and the legacy of lead poisoning that is resulting as a result of that transportation of potentially hazardous waste. I'm sorry, maybe I'll take this off. It's just a little bit annoying. So we also talked about the policy differences that are necessary to support the clandestine activities taking place with the shipment of this electronic waste, and why we need some sort of coherence in the international policies that were developing in Europe primarily, but supposed to protect people in the developing countries where the risks are transported. But also the European Union, the European Commission has probably the most advanced policies in terms of restriction of hazardous substances in electronic products, the Waste Electrical and Electronic Equipment Law. But internationally, the Basel Convention under the United Nations really did not do much. And there were many differences across these policies so that there are loopholes everywhere you look. So the work that I will talk about next is the toxicity hazard assessments. Are these products actually dangerous the way that they are processed? And what are the real risks? Because there were naysayers about the policies that were imagined. They were too stringent. They're going to hamper trade. People will not get jobs. This is a very important labor issue for developing countries. But we didn't argue against the employment and the jobs. But if it's going to be done, it should be done in a safe manner. So I built on some of the work that I'd done earlier, trying to develop methods to assess how human beings are exposed to toxic chemicals, particularly metals, and whether we can use proteins in particular to get a better measure of exposure and also the linkage to disease. This was one on mercury, and we looked at how mercury is transported in the environment and how this particular enzyme can help us indicate potential hazard. We also created a biosensor for lead in soil. This was very controversial because the EPA has rules, the U.S. Environmental Protection Agency has rules about how much lead should be present in your backyard soil or in the dust on your windowsill before action needs to be taken. But those laws are based on chemical analysis as opposed to biological interaction with the lead. And so what we did was to use the same enzyme that humans respond to when we are all exposed to lead. And the first symptom will be anemia, because this enzyme is the first enzyme in the synthesis of heme. So if you block it with lead, you're no longer able to synthesize hemoglobin, and anemia will be the first endpoint, and subsequently all kinds of things will follow, including IQ deficiency, kidney disease, heart problems. And so we built on this work to think about how best to check that the chemicals that are coming out of the electronic products, the way they are being processed in these facilities around the world will pose substantial danger. The first study to show that cell phones should be designated as hazardous waste, which means for the state of California and nationally, with such designation, you can no longer throw these things out into the domestic waste stream. We published this in 2007, and since then many states have enacted laws about cell phone disposal. We're still waiting for the federal action on that, but I think ultimately they hope that the states will take the responsibility and pass the laws. But as of now, I think about 50% of the states have these laws. A lot of them have laws pending, but not quite yet. Typically, these methods are meant to simulate the worst-case scenario. So If you have a disposal of large numbers of phones or computers, what's the likelihood that the metals in those things or the chemicals will end up in river streams, groundwater, under what we'll call mildly acidic conditions? So we essentially take a sample of what's been thrown out, and we shred them, and we go through this tumbling to leach out under mildly acidic conditions to simulate acid rain. And we analyze for the chemicals and try to link them to outcomes, including birth defects, brain damage, heart, liver disease, kidney damage, nervous and reproductive system disorders, and skeletal system damage. We also look at organic chemicals that can cause cancers and other non-cancer diseases. One of the first things we confronted was that if you look internationally, there are differences in the ways that policies require that you do those tests. None of them are based on biological response to the chemicals, as I indicated with our biosensor work. But we have here example of the difference between what will be required at the federal level, the US EPA. The pH is kind of an indicator of acidity. You can see that the acid level pH 4.9, but they also expect that you shred down to a particle size of 9.5 millimeters. In California, we use these two tests. The waste extraction one is very interesting because the particle size is less than 2. So you'd expect more things to leach out, even though the pH is about the same as the federal. Whereas the TTLC, or what they call the totals test, the pH is very, very acidic at 1.0 or less. As expected, if you follow these different methods, you come up with different chemicals leaching out of the products. And according to the EPA, the only reason to classify cell phones as hazardous waste is because they contain too much lead. This is the average that we measured. This is the range. This is what the detection limit of the method is, and this is a federal law. It should not contain more than 5 milligrams per liter of lead, and we're measuring an average concentration of 87.4. What this means is if a manufacturer wants their products not classified as hazardous waste, because it's a lot more expensive to dispose of hazardous waste than regular waste, all they'd have to do is reduce the amount of lead in those products. And that's a good policy to have. And it will also help those children and people who work to try and recover the gold without being exposed to the lead. However, if you are a manufacturer who wants to do business in California, according to those, the totals test, it's not just lead, even though we did find consistently that there was just too much lead, but there was also antimony, chromium, copper, nickel, and zinc that will contribute to ecological damage and also to human health. So it wasn't a trivial thing for a manufacturer to say, oh, we'll redesign the phone and take all of these things out if you want to sell them in the state of California. But we also wanted to make sure that there is some consistency between what the federal government requires and what the states require, especially because some of our collaborators have demonstrated that this is not just an academic question. In a study of children in the village of Guyu, you may have seen video presentations about this that the TV show 2020 did. They actually sent people to Guyu. But this research looked at 226 children less than 6 years of age in 2 different towns. In the village where they process e-waste, the 165 children had blood lead levels up to 32.67 micrograms per deciliter with a mean of 15.3 micrograms per deciliter. In the United States, if these children were here, this is already exceeds the level where they need to go to the hospital. I think we now have an acceptable level of about 5 micrograms per deciliter, although many of my colleagues believe that there's really no safe level of exposure. I think for all of us in this room, our levels will probably be about 1 to 2 micrograms per deciliter because of just ambient exposure. So this was a very significant confirmation that the lead that is present in these cell phones actually do make it into the blood of the children who live in that village. Not all of them actually do the processing. Some of them just live there, drink the water there, breathe the air there. And their blood lead levels were statistically significantly higher than children who live in the next village where this problem does not yet exist. We also began a series of studies to not only inform those who are processing the e-waste, but also to manufacturers to see what they can do to reduce the burden of disease associated with their products. Incidentally, the Nobel Prize last week was awarded for the people who invented LEDs, and I'm not bashing their invention. As I mentioned, technology is always a good thing. But we were also the first to kind of think about the new uses of light-emitting diodes. Now we used to only see them with the exit signs because they're low energy, they can be on forever, and nobody really cared. But over the last 5 years, you can now buy LED products that are meant for children in their toys, for Christmas lights. They're also the reason you have flat, very, very flat screen TVs and computers and cell phones. And we were very interested in the way LEDs are manufactured because they are primarily very small electronic products. So we did a study, essentially the same kind of study about what leaches out when these products are eventually thrown out into the domestic solid waste bins. And we found that there are many, many chemicals that leach out, and some of them contribute to cancer. We use a model developed by the US EPA called TRACY to determine how much of this contributes to cancer risks and non-cancer risks and to environmental risks such as water pollution affecting fishes and other organisms. So there is, in the LEDs that we tested, there is probably the red version of the LEDs is the most dangerous. And arsenic was the biggest concern, which causes cancer. Lead remains a problem for these products, contributing to non-cancer risk, but it's cognitive deficits and other things. You may have seen also in LA that there was a big brouhaha about copper in the water, in the marina and the bays. Copper you use it in your swimming pools because it kills algae and other aquatic organisms. And so it's not something you just want leaching out into natural water systems. So we gave manufacturers an opportunity to redesign the LEDs before they become really huge components of the solid waste stream. I have to say that I've never been attacked as much in the popular press as when we published this result. The reason was that at the same time that we published it, the Congress was debating an initiative actually originating with President Bush to change all of the light bulbs from incandescent because of climate change concerns that we will no longer be able to buy the nice incandescent bulbs. And LED manufacturers were clearly trying to corner the market. And so any indication that this is a dangerous or toxic product did not sit well with them. So we did persevere, and we decided to actually test what they were selling as replacements. We compared the incandescent bulb that you can no longer buy if it's above, I think it's 60 wattage, with the compact fluorescent, which also contained mercury, and the LEDs, the small and the big ones. Of course, we found the same results because these are small electronic products. The design is the same as you would have in the semiconductor piece that runs your computers. And again, we were very fortunate to attract a lot of press. Many were not very nice, but you can't argue that these kinds of data just allow manufacturers to push harder to find safer products, and also for consumers to know that if you used to throw your old bulb into the trash and you replace them with this, you can no longer do the same. And so there has to be a change in behavior about what we do with the solid waste stream. Recovery allows us to also mine some of the potentially precious materials used in them, but particularly removing the toxic risks from environmental systems that ultimately come back to haunt us. We did work with batteries, especially after Apple came up with a new design for the iPhone where you're no longer able to take the battery out yourself. Terry, can you take your battery out and replace it? Well, we thought that was a terrible design because that meant that you can no longer just replace the battery, and it adds to the short life expectancy of the phone, but also people who work in those artisanal industries cannot simply disengage the battery and recycle that separately. So we looked at the new lithium-ion batteries and found that, again, there are so many things that potentially contribute above what the state and federal levels in green recommend and what is present in those batteries. Cobalt in particular and chromium were very new problems. But the lead remained, as well as the nickel. That was also not a very popular publication with the manufacturers of those products, because they are seen as advancing the field, but ultimately they're still not at the level where they should be mass produced, where there is no instruction for people on how to recycle them. Recently, this was published this year. We wanted to simulate, rather than the leaching, what happens when people in these small towns actually burn the e-waste. They burn the plastic away to get at the metals that they are seeking. And so we simulated the burning at about 800 degrees, which is what an open flame will do. And then we collected the ash, essentially in this diagram. And the ash we analyzed for toxic chemicals. And then we used the data to feed into a model called USTOX that's developed by the United Nations Environment Program and the Society for Environmental Toxicology and Chemistry. And that gives us indication about what's potentially negative impact on aquatic and soil-based organisms, as well as what kind of diseases are associated with those chemicals. So, for example, for metals, in terms of environmental impact, again, it's copper and nickel. I'll go through this relatively quickly. For the organic chemicals, there are a whole slew of chemicals that we found, including dioxins, which created a lot of the risks. For metals that cause non-cancer, beryllium, which is associated, we think, with plastics, and this was a new one that we found. Lead is still there in many cases, but beryllium and chromium were newer risks than we expected. For organics and for non-cancer risks, it's anthracene, and furans. We've known about these chemicals for a long time, and we have no idea how to get rid of them, except perhaps to change the specification of the plastics. For metals and cancer, nickel was in the news recently because there was a kid, I think it's Massachusetts, who had some nickel skin problems and accused Apple. There's a little bit of nickel on the surface of the Apple phones. They did say that they've taken them out since then, and it's not likely to cause the kids dermatitis. But it's a serious concern for long-term exposure, not just for skin, but also for cancers. Chromium, if you've seen Erin Brockovich, you know the link between chromium and cancer. For organics, the furans, again, were a big problem for cancers. We created a chart for manufacturers to think about how they can change their way. So how do you, the biggest picks were, removing nickel from circuit boards will be one of the biggest issues. Also nickel from batteries and zinc from the plastics, and of course a little bit of lead. For the organics, the dioxins from batteries was a problem if you burn these things. Also methylene chloride from plastics was a big opportunity to redesign things and create less risk if you're going to have these kinds of artisanal mining of the products. I wanted to spend some time to talk about the what we're doing in terms of green chemistry and alternative assessment to replace some of these dangerous chemicals in the products. We've worked for some time on lead-free, because lead is one of the most notorious and dangerous. And the problems with lead come not just when you're using the product at the consumer level, but from the mining all the way to disposal, landfilling, incineration. And even during recycling, workers are also vulnerable to its impacts. So we did a study on how the electronics industry can replace their tin lead solder with lead-free. The manufacturing, the technology is there, but the adoption of what to use instead is not as straightforward as we had anticipated, which led to a lot of industries asking for exemptions. So the aerospace industry first asked for exemptions because they didn't want to risk having a plane breakdown, because the soldering with an alternative lead-free solder was not as tested as possible. So they have the exemption. The medical industry has an exemption. But it's probably going to spread beyond those two industries, which means that we're still some time away from adopting the lead-free solders. We looked at creating flame retardant-free electronics by using simple flax fibers and non-halogenated flame retardants. We use melamine polyphosphate in this case. There are still challenges with the design and mass production of such things, but it's possible. This was done in collaboration with some of our electrical engineering faculty here. We also look at different ways that we can disassemble electronic products so that they don't need the acid baths that are essentially posing a lot of hazard to people, or the burning that we saw. Just using really hot steam would do it under different circumstances. We've looked at alternatives for solar panels, which is also increasingly going to enter the waste stream in large numbers as the incentive to replace energy consumption with solar intensifies. In that study, we looked not only at the process of making solar panels, but also the actual materials that are used for the panels. And we came up with a recommendation based on the current technology, what would be ideal for manufacturers to adopt. We've tried to codify these alternative assessments in what we call the selecting materials to achieve reduced toxicity products and processes. When we tested this with something we all have at our homes. This is the product that controls how much electricity you're using at home. And that manufacturer worked with us to create a safer alternative. This is not always straightforward. One method we developed it's a statistical analysis method, and we used it, for example, to know the difference between a bisphenol A plastic. Many of you may have bought this at Target, or if you're shopping for a water bottle, you'll find some signs that it's BPA free, but is the alternative actually safer? Most of the times it's because we don't have enough information on the alternative, and we kind of assume that it's safer. What this method allowed us to do was to, in the absence of information that's comparable, you can still make a policy decision about which one to recommend for consumers. One of the problems that we have in this respect is the fact that what we develop here in the US is not necessarily what's going to be adopted in other countries. So we still have a long way to go to harmonize the models that we use internationally. There's a lot going on in Europe that we're not able to replicate here, but we're typically a little bit slow in developing our own models. And in this case, we compared a European model with EPA standards, and we found some discrepancies that will mean a product can be sold in Europe but not here. Others will be considered safe here and not in Europe. So there's still a little bit of a long way to go. And there are activists who are working very hard to force industry to change the way that they manufacture. This is Greenpeace hanging this sign on Dell computers, Windows. Dell now, if you want to buy a Dell computer, you can go to the website and pick a lead-free one, and you pay a little bit more. But the computer is not the biggest market for their products. And so they have incremental successes and progress. But the whole industry has to change, especially because manufacturing takes place in different parts of the world with different rules, which is why we thought that the harmonization is one of the important things that activists can help us with as we develop our own models here. I don't want us to take too much time, so I have maybe 1 or 2 minutes to talk to you about consumer participation. This is done in collaboration with our colleague John Daniel Safaris here in economics and civil engineering. So we surveyed more than 2,000 US residents about their knowledge of these issues and what policymakers can do to increase that knowledge, to make sure that people comply with the law saying you can't throw your phones in the trash, and how much you're willing to pay to recycle or for a green phone. A lot of people are willing, obviously, especially even those who have not tried to dispose of anything before. But the models that John Daniel runs helps us identify targets of opportunity. So most people are willing to pay to drive 6 to 10 miles to take things to a collection site. Most are aware of the waste. Most know that waste have toxic materials, but yet a lot store these materials at home until they move, and then they throw them out into the domestic trash because it's too complicated to follow those laws. We know that women are more likely to recycle, and people living in rural areas are more likely. This is the baseline. Anything below that, no college education if it's more than 5 miles, no curbside collection in your region. If you're between ages 18 and 35 or above 65, less likely. So these are the people we want to target the educational programs to. Policy development, we've been working with the Basel Convention folks. The United States is not a signatory to the Basel Convention, so that's a problem. This article came out after the World Health Organization produced evidence linking e-waste exposure to disease. And we wanted to, even though the evidence is not completely compelling in some cases, we wanted to make sure that we don't stall policy development waiting for the full, indisputable epidemiological studies that we all like. We still have people being exposed regularly, and we should continue with the policy development even as we collect the data on impact. So we've been collaborating very broadly. This is the Basel Convention Regional Coordinating Centers. We have a proposal pending to do a global environmental and occupational health hub for e-waste collection, primarily with colleagues in China, in Nigeria, and there is a group in Iran that we are going to be involving in that project. One of the initiatives we are working on to make sure that the international policies and regulations are adopted and applicable in a coherent and harmonized fashion across different regions and different countries is to collaborate with the regional and coordinating centers of the Basel Convention. There are 14 of these all over the world, and we have been working primarily with the group in China, number 5, and the group in Nigeria, number 2, to develop strategies for dissemination of information to workers, to the public, and to design research projects that can move the field forward. In the state of California, we are also interested in working across the state with research collaborators in the UC system to help the state in the implementation of the Safer Consumer Products Law that became effective on October 1st, 2013. It took 5 years between the time Governor Schwarzenegger signed the law to the implementation because of the need to ensure that it doesn't compromise the economy, that it's legally enforceable, and that it will not stifle innovation. This is called the Green Chemistry Law, and I participated in the Green Ribbon Science Panel to help the Department of Toxic Substances Control craft the best possible law. At the federal level, one of the things we're also doing is to make sure that the strengths of research within the University of California is coordinated enough to be useful for those other states that are thinking of developing laws similar to the Green Chemistry Safer Consumer Products Law in California. So we proposed to the Office of the UC President to establish an Institute for Smart Products and Processes. This is safe selecting materials for to achieve reduced toxicity, where we will focus on interdisciplinary research in materials life cycle assessment, toxicity hazard and exposure assessments, and alternatives analysis, decision science, and policy development. We believe that this is necessary to sort through the 83,000 or so chemicals in production, with more than 2,000 of them high production volume used in all kinds of materials that end up in consumer products and in our environment. The national level, a few years ago, President Obama announced the creation of the Materials Genome Initiative. This includes things like not only materials for security, for healthcare. He wants to ensure that we are ready to face the next century in terms of what the needs will be for the growing population. And he cited the lithium-ion batteries, computers, iPods, iPads that I showed you that we've been working on. And if you notice, it's also holding some fluorescent tubes. And one of the things we responded to this initiative is that it really needs to pay attention to toxicity. So even though the goals are laudable, a crucial perspective is missing in the research foci, that these materials must be sustainable and they should not threaten environmental quality and human health in their production, use, or disposal. In the figure to your right, I present a result of a study we did looking at the California experience, where there seemed to be big discrepancy between what the corporations who manufacture and the public think about the priorities in research for sustainable materials and safety. We believe that more work needs to be done to ensure the convergence of views about what's really good for the economy must also be good for the public. We are very much interested in continuing to work with the Department of Toxic Substances Control in California and their equivalent agencies in different parts of the world. I will conclude this presentation by focusing on each of the 6 or 7 topics we've covered, that I hope I have assured you that electronic waste is a fast-growing category of urban solid waste worldwide. And it's not just fast-growing, but it's also potentially very toxic, and as demonstrated, that risk affects all kinds of vulnerable populations in different parts of the world. Manufacturers can help solve part of the problem through design for the environment strategies, and consumers should also be able to participate in waste management through recycling, but we need to support them with information and infrastructure, that the national and international policies to characterize the hazards of electronic waste are not currently harmonized, and we have to work toward making sure that happens. And the green chemistry approach can be integrated into policies and practices at all levels, so that research to fill the remaining gaps in knowledge, technology, and translation to effective practices becomes something we think of pretty routinely. I would like to acknowledge the source of support for a lot of this work through the National Science Foundation, the Minerals, Metals, and Materials Society, NIH, and the old UC Toxic Substances Research and Teaching Program. Many students collaborated with us, and the 4 PIs on the original project are also depicted in this picture. I also would like to finally dedicate this presentation. The Nobel Prize was awarded last week for peace to Kailash Satyarthi, who gave up his career as an electrical engineer to fight child labor. This child labor is not just working under circumstances that adults work, but in this particular situation, under circumstances that nobody, grown-up or adult, should be working. And to them, we really hope we come up with cleaner ways advancing technology. Thank you very much. So I thank you for your attention. If there are questions that I can address with the remaining slides, I will go into them. But they're mostly about our collaborations, but this is a good place to stop. So thank you. Yes. Uli.
I heard the opinion that machines are much better in sorting waste in general than people. So can't we expect that waste management takes the great tons and identifies technical waste and does it by themselves rather than us sorting it out and bringing it somewhere?
You are absolutely correct. There are two lines of research on that. One is to label the products so that machines can read what components belong where. The problem is not all the components can be recycled together. So plastic components, metallic components, if you mix them too much, you cannot reuse those products. So the labeling is being funded by EPA. The second part is manufacturers, in an attempt to become unique, create situations such as the battery cannot be easily removed, which requires a little bit of thinking beyond the machine level to know how to sort and separate. Part of the challenge is actually the recovery, that people have to bring this to a place that can accept them. But there are robotics, research in robotics about taking these components apart, that I think in Japan, this is very advanced actually, because they depend a lot on incineration and mechanical sorting. But the problem is still bringing from consumers to a central location. So the research on robotics, I think, will be very, very helpful in the near future about sorting and dismantling. The work we did with the Chinese collaborator on dismantling was mostly robots doing it with industrial waste stream. So you could merge the recycling operation with an industry that just wastes the steam, so that it's all automated and you can recover the components, many of which can still be reused. The biggest challenge is that the places where currently people want to recover the precious metals, the infrastructure for such automation is just not there. And as I mentioned, the International Labour Organization is very concerned about banning the export of used computers and used phones, because in developing countries, it's a source of employment and potentially relatively affordable products. And it would take a lot of brain power to think about how to automate the labor in those places without compromising. So one of the ways is to teach people how to use personal protective gear if they are going to do it manually, at least to protect them from the health impacts. And hopefully we'll come up with cheaper robots that can be used also in those contexts as well. Yes?
Deli, this is just fascinating. I'm interested in the implementation of this in the general public. When we're dealing with manufacturers, we can impose legislation on them. But the only way to bring the public into this is by public education. Is there a strategy in place for that?
Yes. So for 3 years, I worked with the California Department of Toxic Substances Control's Green Chemistry Initiative, which became law last year. And part of the problem is what you identified. Most of us still, if I had said, raise your hand if you know what the law means, we wouldn't know where to begin. So the education has to begin at the local level. For example, the city of Irvine. So I do pay some attention to the waste management, my bill. And every week, every Friday, they come, 3 bins. One for yard waste, one for food waste, and one for recyclables. But the recyclables only take paper and plastics and some metals now, but they don't take electronic products. So one way to educate the citizens of Irvine or most of the Orange County cities might be to ask the waste management to give us the fourth bin, right? Even if they don't come every month, every week, maybe they come once a month, you put all your batteries and cell phones and old computers in that bin. It wouldn't cost that much more for them to run that operation, because now all they want you to do is to call them or you drive it to them. And most of us will not do that. If that bin is sitting there on your curb, it's a mental memory. You have a memory, okay, there's something I need to do with that bin. And I think that has to start the education process, because then people will start asking questions and are more informed about what doesn't go into what bin. We had the same process because people have studied before and after the implementation of curbside waste disposal. And it changes people's attitudes about sorting and separation and recycling. If you don't have a recycling bin there, you're not gonna, even paper will go somewhere else. So that's one thing we're working on at the local level, that it becomes a state. Some rich cities can probably do it before others, but the state can also support the cities that are not able to implement it right away. We pay a lot of money now for large-scale recyclers of e-waste. The state of California, we pay per ton of what they collect, but we don't really do much in terms of monitoring what they do with the waste they collect. I think most of it actually ends up still being shipped overseas. But we could, move some of that money to the public education so that it's actually done right.
So the answer is that to modify the trash and recyclable collection process in every community is the way to proceed to educate the public.
Absolutely. I would put money in there. Yes?
So I think there's a lot of legislation about what companies that I think a lot of companies are required to take back all computers or cell phones. But I don't know if there are a lot of legislations covering what they do with it, hence the problem is Exide. And I know a lot of companies are shipping all the old computers and mobile and stuff as garbage, and they're paying for it by the pound and shipping it to other countries. So does your research focus on any of that?
Yeah, so you mean about what manufacture?
With the waste product that they receive,
right.
And then what they do is sometimes they recycle, but maybe it's much cheaper to send it to developing countries.
Right. So it's a good question, because it's why we want this collaboration. So according to some of the work that we did and others, now it's no question that electronic wastes are hazardous, right? The Basel Convention was the first international law to say countries can no longer ship anything that's called hazardous to another country. Unfortunately, the United States did not sign the Basel Convention, partly to protect trade because of the trade deficit. So when vessels come from China, they bring a lot of expensive goods, your phones, but we don't sell a lot of things to China. So the vessels go back and they want to make money anyway, so they take whatever, paper, plastics, e-waste. And that's been a problem because now the US is not liable. If they do that, they don't break the Basel Convention that they are not signatories to. But if you have a strong network that enforces the Basel Convention, then such practices will no longer be allowed, which means that the waste will stay here, which means that we would have more pressure on companies to do the recycling here as opposed to the cheap labor. We have a very big problem with batteries. And if the Exide problem didn't come up, we wouldn't know about it as much. But a lot of the batteries we recycle, Exide's largest operation is actually in Mexico. And there are big problems there as well, before the LA problems started. So in many ways, the North American Free Trade Agreement kind of contributed to that shipment of old batteries to Mexico with the environmental problems that resulted there. It's very expensive to treat waste here because we have tough environmental laws. So the reason it's cheaper to do it elsewhere is because they don't have as tough environmental laws. But what we have to do is make sure that our laws, we also invest. We like the laws to be very strict, but we also have to recognize that products are probably too cheap. You know, how much we pay for them should include the human health and environmental impact. So if your cell phone costs a little bit more, we should know what we're paying for, not because it's cheaper to produce it elsewhere or to take the waste elsewhere. So you know, I think the public also has to be carried along in this sense to pay a little bit more. Manufacturers will not likely reduce their profit margin voluntarily. But we have to do it either by policy or consumers paying, you know, voting with their money. All right, I think we have some food waiting, and I'd hate for it to get cold or flies. And so ARB ground floor, we can continue the discussion. Thank you again.